So let's look at the formula n choose 2 times n, all divided by n plus 1, to see how this generates the numbers in the Catalan series. We'll begin with the numerator in the formula, that is n choose 2 times n, which expresses the number of ways to pick n items from 2n objects without repeats or regard to the order that we choose them. To get a better idea of what's really going on, let's start with a pile of n balls and a row of 2n buckets. We pick a ball, any ball will do, and we put it into an empty bucket, any empty bucket, and continue this until we have placed all n balls into n buckets from the 2n that were available. The number of ways to place the n balls is calculated by n choose 2 times n. Now, to get back to our Catalan strings, wherever we have a ball in a bucket, we can say that's the same as having a 1 in the string. So each string has n ones where the balls were placed and n zeros where they weren't, which obeys our first rule of equal numbers of ones and zeros. The second rule of always having more ones and zeros when moving along the string is captured through the division by n plus 1, which is the denominator of the Catalan formula. We'll explore that in the next lesson, but first you can play with the verb explode, which will return the number of strings that the numerator generates for each value of n. If you guess the name explode comes from how fast the results increase as n increases, you would be right. Mathematicians often refer to this rapid increase as a combinatorial explosion. As we shall see later on, managing this explosion is vital in our quest for the millionth Catalan number.